and over 50 articles in one top journal alone. The discussion was all the more impressive because the speed of light was generally held to be a constant. The problem was that if the speed of light was changing, it was going to be potentially disruptive to the new physics that was developing. And it was more particularly the case in some atomic constants were also changing, whereas others were constant. The reasons why were unclear. Burge, who was the keeper of the constants, as I mentioned him earlier, he kept track of these variations right up until 1941, August of 1941. Then something strange happened. He wrote an article in Reports on Progress in Physics on the general physical constants, quote, with special reference to the speed of light. The introductory paragraph read in part, listen to this. This article is being written upon request and at this time, his emphasis, upon request. A belief in any significant variability of the constants of nature is fatal to the spirit of science as science is now understood. This closed the whole discussion. All the changing values of the atomic constants and the speed of light, okay, they're not changing at all. Ignore the data, we'll run with the theory. All the constants were declared constant and physics was not going to be sidetracked. Their theory was going to be intact. So the issue was now buried, but it was not dead. The trend in the atomic data continued. This way of doing things is not science. It's not, at least it's not good science. Science should look at the data. Why was Burge so upset back in 1941? Well, if c was high, if the speed of light was higher, it inevitably led to a chain of reasoning which showed that there was not enough time for evolution. And tomorrow we'll show you how this all works. But for now, they knew that evolution had to happen, and so the speed of light had to be constant. I started investigating the changing atomic constants, and especially the speed of light, back in 1980. In early 1987, we had an invitation to write a major white paper on the atomic constants for internal review at Stanford Research Institute International, SRI International. It resulted in a 90-page report, The Atomic Constants, Light and Time, co-authored with Trevor Norman and myself. All told, there were 638 measurements of 12 atomic quantities by 41 different methods, published jointly by SRI International and Flinders University in August of 1987. The data trend was compelling. The professor of statistics at Flinders University gave us 100% support and asked us to prepare a seminar on it because the whole math department was very, very excited with what we were doing. And around about December of that year, in December 87, V.S. Troitsky from Russia published in Astrophysics and Space Science the evidence that there was a decline in the speed of light over the lifetime of the cosmos, and associated atomic constants were also varying. Pardon me. This was similar to what we had reported. And then someone contacted SRI International and Flinders University and said, are you aware of the fact that this research leads to a young universe and is against the theory of evolution? I was banned from the math department at Flinders University. My co-worker, Trevor Norman, eventually lost his job at Flinders University because of this. In 1993, a Canadian statistician, Alan Montgomery, and a US physicist, Lambert Dolphin, examined all the statistical criticisms which were coming in since 1987 and re-examined the data trends in the 87 report. They published a statistical analysis in a peer-reviewed journal which has never been refuted. What was the conclusion? The conclusion was that the analysis gave full support to the data trends that we had outlined in our 87 report. Since then, a variation in the speed of light has almost become a respectable idea among some astronomers and cosmologists. For example, Moffat in the 1990s, and Albrecht and Meguijo in 1999, John Barrow in 1999, and many other astronomers stated that many astronomical problems would be resolved if you had a very high value for the speed of light at the inception of the cosmos. Paul Davies followed this up in 2002, and there's been over 50 articles about this ever since. One problem: they have adopted what they call a minimalist approach. This means that they're varying the speed of light and only other things that are absolutely necessary. They are not conserving energy in the process. And here's where the problem comes in. If you're not conserving energy, in the equation E equals mc squared, m is constant, c is going sky high, so the energy from any given reaction must also be going sky high. The work that we had done in the report in 87, and I spent months on this trying to find out what was happening. Some quantities were going up, others were going down, some went part way. I juggled my equations around. It turned out that this whole thing only worked if energy was being conserved in the process, so that as the speed of light went higher, atomic masses were lower. And so you actually had a position in which it wasn't a minimalist position, but it was a position in which energy was conserved, and you find that all of your physical and chemical processes remain in balance. These guys are not doing that. And I had a chance to talk with Professor Ulbricht at Davis a few years ago, just after his report came out. And I said to him, why are you dropping the speed of light dramatically shortly after the beginning of the cosmos? He said, well, we couldn't get the data to agree with other constants if we didn't do that. I said, it will work if you conserve energy in the process instead of adopting this minimalist position. He said, yes. He said, we looked at that, but he said, if we conserved energy, we could not achieve all we wanted to do with our theory. Okay, they're not running with the data, they're running with the theory. So, okay,